This is what is known as a Dynafocal engine mount for a Lycoming engine. It goes to a hot rod experimental kit-built airplane that somebody, whoever, the previous owner, whoever, did an extremely hard landing on that airplane, and they broke a tube, for Pete's sakes. Man, they must have knocked the fire out of that nose gear to break this tube. It not only broke the cross tube, it sheared one of the bolts completely in two, and it's broken. This particular tube here is broken completely into there, and it's got a substantial crack going across here. Now, this tube, this one, and well, I guess these two down here, and those two, and perhaps that one and that one. Well, nearly every one of them, except for the Dynafocal ring. It's all well, this is 3/4 65 thousandths wall. 0.65. I can't tell for sure what these are. I called the manufacturer yesterday, and I had a talk with one of their engineers in their technical support department, and he sent me some information. But those various tubes have different wall thicknesses, and they're all pretty doggone heavy. 65 thousandths for a cross tube is pretty dang heavy, but of course the nose gear bolts in right here. And believe it or not, that's what holds the whole nose gear in, right there. Or that's what it bolts to on the motor mount. So it was taken to sandblast, and all of this area here adjacent to the weld, all the way around and down here on these tubes, and all of that was sandblasted clean. One of the reasons for that is because you want clean metal when you weld in the new piece. And we're going to go back with 3/4 65 thousandths wall, same as this. And that is, according to the factory, what I should do. They said if I wanted to, I could add gussets. The Australians are adding gussets because they've got sod runways. But he said you don't need to. He said the motor mount itself is so substantial that this should never happen unless under one of the most severe landing loads you could ever imagine. But anyway, you've got to have clean metal to weld back into. So I sandblasted it all. Plus, one of the things I'm going to do when I get this tube out and get all the old weld ground out is have these tubes for about 2 inches on either side checked with a dye penetrant. We'll look at it with a magnifying glass, and then we'll perform a dye penetrant test just to make sure there are no other cracks showing up in those tubes. So the next step right now is to blow all of the sandblast dust off of it, and then clean it all up with a little alcohol. Cut that cross tube out. Well, first of all, we're going to jig it. We're going to put that cross tube back into place, jig the motor mount solid just the way it's supposed to be. Then we'll cut that piece out and grind all these welds out. Clean it thoroughly, do the dye penetrant, cut the new tube, fit it in and weld it up, and it'll be ready to roll. Okay, we're going to do our due diligence with the cleaning. And the reason why we want to be absolutely anal about this is we don't want to weld in any sand inclusions. So we'll be cleaning this at every step of the way. We'll be grinding that, and we'll clean it after that too. We don't want any grinding wheel inclusions welded into the weld. I'm going to be absolutely anal about all of that. This is a highly stressed part. You want to give it a fighting chance of surviving for the rest of its, well, its mechanical life, however long that may be. And, you know, some of these airplanes last 100 years. I mean, you know, not many, but there are some that have been restored that are 100 years old. World War I airplane, or yeah, and even before then. So we'll clean all the other tubes too, just to get that sandblasting powder off, so that it doesn't even accidentally, you know, find its way up here to become an inclusion in the weld. So we'll do that off camera. Look at that. They've got some kind of silicone around these motor mounts down here that attach to the firewall. I guess they were trying to plug up any kind of air leaks or what have you. Who knows what they were doing. It's a mystery what some people do. Now, like I said, this was a kit-built airplane. This is one of the airplanes that never was certified. They kept adding horsepower to these airplanes. And it started off with an 0235, I think. And it wound up with an IO 540, believe it or not. Well, this is one of the ones that, and I don't know why they did it. Surely they had good engineers, because later on they went back and did it with the other models that they wanted to, you know, get certification on. But when they did this one, they didn't, you know, give it more horizontal stabilizer, more vertical stabilizer, more rudder, more elevator, you know, stuff like that an airplane typically needs. When you start adding power, you're usually needing to add a little bit more vertical stabilizer and horizontal stabilizer and so forth and so on. So anyway, but they're fast. I mean, good gravy. That's what they're built for speed. And that's one thing they do great, is fly fast. But physically, they're really a small airplane. Two-place, of course. Okay, we'll just keep cleaning that until we're satisfied we've got all the powder off. And like I said, we'll do this over and over again throughout the whole repair process, just to make sure. Due diligence, my friends. Overkill, perhaps. Yeah. Peace of mind, absolutely. Rather spend the time now, doing this and not having problems later on, than getting a knock on the door from our friendly FAA, who's going to be there to, of course, help. I'm here to help. Alright, next step is to jig it. Well, look at that. On the bottom it's cracked all the way through. It doesn't look like it's that bad on top. And it's broken completely through there. Man, they hit hard. Shoot. Okay, I don't know if we can see that. There's one of the bolts that was used, and of course it's in a bushing right now, and boy, that bushing is on there tight. But you can see where it's sheared right there, just adjacent to the shoulder of the bolt, I guess, right where the thread started. Sheared that thing in two, and believe me, man, it takes a load to do that. The scary thing about the whole thing is, it had been flying like this for a while. That was not a new brake. It's been like that for a while. Well, you haven't lived until you've spent a morning trying to find nuts and bolts for your jig that you're going to need. Now, Cliff gave me an AN4 bolt. Well, Adrian, his A&P mechanic, gave me one AN4 bolt that's the right size to span here and here. But it's 6 3/4 inches, and besides that, you don't want to weld with a brand new AN bolt. I mean, good grief, you're going to take the temper out and ruin the bolt. We're going to spend the next hour or so jigging this baby up in preparation for grinding all of this out and all of those welds out, and getting ready to fit our tubing. And here we have Mr. Competent Airframe and Power Plant Mechanic. He's going to start the jigging process for us. Anytime you're dealing with something like this, as our mechanic is showing us, be sure and hold that item that you're drilling in some sort of a clamp. Maybe we can get this started, get it going. Mr. A&P told me he's anxious to get this thing finished and out of the shop. He's got 10 million other projects going. He's going to gently squeeze this in until it's almost touching and in place. And then, now he's showing us he's going to fit this piece. He's going to take it over to the saw and fit it, cut it a little bit oversized, put it in here, and he's going to clamp that together, and that's going to jig that right there in place. Looks just about right. We'll take that over to the table saw and cut that just outside the line. Fit it in and see what we've got. Now momentarily our mechanic is going to be grinding that weld out, and he asked me to remind everybody to be sure and wear your safety glasses. And you know, I have to concur with that, because there have been 2 times I've spent a couple hours each time laying on a emergency room bed having metal particles dug out of my eye because I didn't heed that warning. Get you some center lines here before you take the tube out, and take a measurement. This is 7 5/16. Okay, we're going to maintain that. Write it down here. 7 5/16. Okay, we'll write it down here too, just in case. 7 5/16. Now we're going to jig up a piece back here to hold this in place. And of course you want to lock those in place so they don't unscrew on you, you know, while you're working, while you're grinding and all that. We'll just double nut it. Okay, we're only partially done with the jigging. Now we're going to jig it back here and then take that out. The Jiggerinsky is coming along. And we see our A&P mechanic has got the Jiggerinsky almost finished. I think he's got one more clamp to go. Okay, it's jigged up. Now it's time to get rid of that. Okay. Before we go on, just for our own peace of mind, I'm going to double check our wall thickness of this tube. I think it's 65 thousandths. And it is, as we can see, I don't know if we can see that, it's 65 thousandths. And we've got a piece of 65 thousandths over there, brand new. Yeah, and they wonder why it takes so doggone long. It took you how many hours? Oh no, that can't be. You're lying to me. Well, I've heard that a million times. Well, that one didn't quite take an hour. It took 53 minutes to do that one. And I've still got to, our mechanic has still got to take a file and work on it a little bit. So by the time it's ready to fit up a tube, probably an hour and 15 minutes, on each one of these. Grinding welds takes forever. I've often said, well, I've always said that, repairing these old airplanes, now of course, this motor mount, it's more feasible to repair it than to build a new one. But if you get into a fuselage that's got a lot of tubing or for instance a rudder, a lot of tubing needs to be cut out and replaced. It's really easier to make a jig and build a brand new rudder than it is to cut all those tubes out, grind the welds down, have it jigged up, fit in new parts and weld it up. The grinding of the welds, man, it's a major pain in your kabooski. It really is, but this is what I did for 40 years, I guess. And unless you get down to it and do it, you don't know what I'm talking. Well, I'm sure you could guess. But there's a major controversy going on right now online. It's the Aranca Lovers Association. I think that's what the name of it was. And there was a thread started by a guy. He says something to the effect of, hey, I was just wondering how much it would cost for somebody to take my Champ or whatever it was, Chief or something, and recover it. And so everybody and their dog had an opinion. One guy even said he could do it for $5,000, which is a load of malarkey. You can't even buy material for that, not today. So I chimed in. I put my 2 cents worth, and I said when I was doing this, the labor alone, I always counted just labor alone to cover an airplane. Now that doesn't include rebuilding anything, sandblast, primer, epoxy, all that kind of stuff, repairs. Just to come in for labor to recover at $35 an hour. That's what I was charging back then. 1,000 hours to cover it. That's pretty much standard. Some people can do it less, some takes more. And believe me, that is a real world figure. And unless you've done it, you don't know. You're just guessing. So, that I put my 2 cents worth in. And there's a guy named Kreider or something like that. I forget his name doesn't even really matter. There's always a smart aleck in the group. He comes back, 35 grand, man. Come on. Well, he didn't obviously read the post. So I wrote back, I said, man, go back and read the post. That $35,000 is for labor only. And nowadays you're going to spend about $6,500, maybe more, depending on the color of paint and the kind of paint you're going to use. For Stitz, I like Stitz, and I like Polytone. You're going to spend about $7,000, probably more than that, because you can bet your hat, ass, and spats that the amount of thinner that they recommend is not going to be enough. You're going to have thinner to clean your brushes, to clean your gun, so. You really need to get an additional 5 gallons of thinner for that superfluous stuff. Then, okay, that covers material and labor, just to cover. Now, if you've got repairs, oh, good Lord, that's a whole different ball game. Repairs like this on a routinely, Champs, Chiefs, J3s, I did them all. There was a guy named Mark Heffley that restored J3s. And he'd get one in, strip it all down, and ship the fuselage to me for repairs. Man, I can't even count how many fuselages on my hands and toes, how many, 10, not 10, 20, maybe a little bit less, fuselages that he sent me that I repaired. And back then, this is going back several years, just for a few tubes to be replaced and this and that and the other, the average per fuselage was $1,200. And then the high would be around 65. And that's doing a lot of repairs. But anyway, how did I get off on that tangent? We've got this ground down. It's ready for some file work. Now we're going to carefully go down and grind on the other one. I'm going to do that off camera. You don't need to be seeing redundancy in action. Progress is being made. Plan on burning up about 3 blades. Go down and get the heavy-duty Dremel cut-off wheels. They last a lot longer than those, those cheap little thin ones that come with a Dremel tool. Just tedium ad nauseum. You know, I've often thought that this must be an awful lot like a dentist, sitting around and grinding on teeth. So I'll get that off camera. Well, getting close to time to do the dye penetrant test. Hopefully nothing else is cracked. Smooth up all of that old weld edges and all of that, so that when we weld it back together or weld the new tube in, you don't have a lot of superfluous old weld material getting in the way. They TIG welded this. I don't know what brand of rod they used. So, you know, I'm just going to go back with the old standby for oxyacetylene. You know, up until I couldn't see anymore, hardly, to weld through a hood, I had a TIG welder, but I liked it. I liked it on heavy material that you can't use an oxyacetylene torch on because of just too much heat sink. But that's about all I used it for. Stuff like this, man, you can't beat a torch. Oxyacetylene, boy, that's the way to go. For steel tube fuselages, and believe me, it's been around for, what, 100 years, maybe more than that. It's still a viable way to weld, an excellent way to weld. I prefer it over TIG welding on a structure like this. Okay, let's clean that up and see about getting a dye penetrant test going.